Welcome to another episode of the Mapscaping Podcast. My name is Daniel and this is a podcast for the geospatial community. Today on the podcast I'm talking with Brendan Ashworth. Brendan is the CTO and co-founder of a company called Bunting Labs. We're talking about Autocomplete for vectorization. Along the way, Brendan's going to share with us why Bunting Labs chose to build on top of QGIS, the challenges around map digitization, what the development process was like, and how this is different from tools like Segment Anything from Meta. But before we get into all that great stuff, I want to thank today's sponsor, Scribble Maps. Jonathan, the CEO at Scribble Maps, has been on the podcast before, and the title of that episode is The Business of Web Maps. And it will be well worth checking that out. It was a very open and honest conversation. And so when someone like Jonathan reaches out and says, hey, I'd like to sponsor some episodes, there's always a bit of back and forth where you work out, well, what is it exactly that you want to say? What message do you want me to share with people? And so this is the message Jonathan gave me. Augment your current GIS workflows and bring GIS to all levels of your organization with Scribble Maps. Now, let's talk about this just for a second. Augment, not replace. And Jonathan was very clear about this. He said, this is not a replacement for QGIS. This is not a replacement for ArcGIS. This is a way of augmenting those tools, making them better, giving them something else to work with. And this, bring GIS to all levels of your organization. This is easier said than done. This is part of my current role as a consultant. And I deal with all levels of an organization. And what you quickly discover when you deal with all levels of an organization is that everybody wants something different. The tools that I'm currently using or tied into using are one size fits all. This is not the case with Scribble Maps. I think if it was up to me and I could start from the bottom, I think Scribble Maps would have been a much better choice if I truly wanted to bring GIS to all levels of the organization that I am working for. So if you're looking to augment the things that you're already doing in GIS, check out Scribble Maps. If you want to bring GIS to all levels of your organization, maybe Scribble Maps is the right choice for you. Book a one-to-one demo today and mention Mapscaping for a discount. I'll put a link in the show notes to make it a little bit easier for you to find. So thank you very much, Scribble Maps. Thanks for supporting this podcast. It's much appreciated. Hi, Brendan. Welcome to the podcast. Real pleasure having you with me today. You are the CTO and co-founder of something called Bunting Labs, and I was introduced to you by an acquaintance of ours, and the reason he introduced me to you was because of some really interesting work you're doing around AI and QGIS, and I guess we could kind of describe it as an autocomplete for vectorization, but we'll talk more about that later on. Just for the time being, perhaps you could fill in some gaps for us. Can you give us a brief introduction? Who are you and what do you do?
Sure. Thanks for having me on the podcast, by the way. So I'm Brendan. I'm the CTO at Bunting Labs, and that means that I have been building a AI autocomplete for QGIS for the past year. So I wasn't originally a GIS geospatial person. I actually got my start kind of in open source software. So I originally got involved with the Node.js project, which is an open source platform for running JavaScript on servers normally. And that's kind of where I initially learned to engineer software. And that really gave me my spark in computer science. And it was only later that I went to MIT and ended up studying physics and computer science there, where I got more into machine learning. And I think you can kind of see that Bunting Labs is kind of at the intersection of many of these different interests of mine. So kind of my background in machine learning, and specifically I studied Bayesian inference at MIT, kind of led me to have this geospatial moment towards the later end of my college career. And that's actually when I was working on a consulting project with a real estate developer. And we were more or less summarizing different neighborhoods in terms of their characteristics with statistics and with neural networks. And it's more or less at that moment where I realized that geospatial data is like extremely powerful. And I was kind of confused as to why other people weren't using geospatial data more. And that really set me on this path to discover geospatial data and kind of the intersection between geospatial data and machine learning. And that's kind of where Bunting Labs came from.
I guess the big unanswered question for me is why QGIS then? Why did you decide to build something on top of the platform that is QGIS?
My familiarity has always really been with open source software. So when I think of software that I can contribute to and software that I can build an ecosystem around, or contribute to the ecosystem in, I think of GitHub. And I think of repositories that everyone can kind of see, learn from, contribute to, and build around. And so QGIS is in many ways closer to my comfort zone than many of the other GIS softwares that are available out there. It's extremely easy to get started with. So we basically built the first version of this plugin in about 2 weeks. And I could do that by learning from all of the other open source plugins that are available. And so QGIS, it's not just this one app that you download to your computer. It's really an ecosystem that everyone is contributing software to and enjoying as a result. And so I think that's why I first got started with the QGIS plugin.
And so my next question is a two-part question. Explain to myself and to the listeners of this podcast what autocomplete for digitizing vectors means for you in QGIS and why that was a problem you wanted to solve.
So autocomplete for vectorizing in QGIS, or another way to kind of describe it is an autocomplete for tracing maps, is a addition to the GIS pen tool. And so if you are presented with raster imagery of some sort, so if that's a satellite image of an area, if that's a rendered PDF of some sort of construction or architecture asset somewhere in the world, and you need to convert that into a vector file with a projection and some sort of like accuracy, you would use the pen tool to digitize that into its vector representation. And in many conversations with GIS professionals, we found that they essentially participated in this workflow extremely frequently. And so they would be presented with oftentimes a PDF that doesn't have any kind of projection with it. They would need to georeference that PDF to oftentimes sub-meter resolution. And that's literally locating it in aerial imagery or maybe on an OpenStreetMap base map and adding control points until the raster layer perfectly lines up with its location in the real world. And then they would get out their pen tool and digitize out lines, polygons, maybe even points that represent semantic shapes from that map. And then they use that and then add metadata to those shapes. And so it's not just lines in your local state plane. These are buried utility lines. And so you would add metadata of the diameter of that pipe. Or maybe these are literally painted lines on a highway. And you are adding metadata that says these were last painted on 2014, August 2014, and they will need to be painted again in August 2024. And this kind of workflow where you would take rasters and then build a meaningful digital file format equivalent of them, we saw all the time. And so, given my background, we started imagining what this workflow would look like with AI. And this is more or less the product of that.
You did a great job answering both questions with one answer. That was brilliant. So given your skill set, your experience, and your interests, if I was you, I would look at this problem and thinking, wow, I bet you I can convert every line that I can see in that rendered image to a vector output, and instead of trying to like trace lines individually. Is that a thought that crossed your mind when you were thinking about solving this problem?
Yeah, and I think it's really funny because my conception of how to solve this map digitization problem is totally different now than it was a year ago when I first started looking at this. So when Michael and I decided that map digitization was a problem that we would tackle, we basically went to the whiteboard and I threw up my design, my attempted solution for what digitization with AI would look like. And I said, it's probably really easy to convert an entire map into its vector representation. In fact, there's an entire academic field dedicated to solving that. If you go online and Google vectorization, especially of images, there's a lot of published research as to actually accomplish that task. And I said, this is a solved problem, surely, and I can build this in 2 weeks. I said that probably 13 or 14 months ago, so I totally take that back. And the first 6 months of me building this was actually very similar to your suggested solution. I did a literature search and found the best performing machine learning models for converting an image into its vector representation. And there are some really high quality research available online for doing that. If you take pretty much any image, we're talking especially like logos, images of the real world, and convert it into its vector format, to your eye, it looks fantastic. It is very perfectly recreating the entire image as an SVG, for example. But when we went to kind of our original design partners and showed them this technology, we realized that it kind of missed the mark. It's like a priori, when you see a map, it's kind of difficult to determine which of the assets in that map are important to have the vector representation. And so we realized that if we wanted to productionize this, we actually had to build a semantic understanding of all of the features in these maps. And that all of a sudden was a much more difficult problem because that's akin to machine reading of maps and understanding. And when we were looking at this a year ago, that seemed impossible. And even worse, when you have extremely important assets that you want a high quality vector representation of, you don't actually trust the output of a machine learning model on its first go. If you were to hand me a geotiff and I handed you back a shapefile, you would actually load it into your GIS software of choice and review it such that it's perfect, such that it's to your standards. And realizing that took about 6 months. After 6 or 7 months of working on that approach, I actually went on a walk with Michael and I essentially came to the conclusion that I was not on a trajectory of success. If I interpolated my progress out, I would not be successful in 1 or 2 years. And so I essentially had to go back to the drawing board. And it was only then, with inspiration kind of from these more recent generative AI models like ChatGPT, did I consider an AI autocomplete. This was never originally going to be a plugin that you run in your desktop GIS software, but we realized that that was actually the modality that people wanted. They wanted to be able to have access to this and immediately review its output.
I think too what you're getting at is they wanted to be in charge. They wanted to have just increase or make me more efficient in the work that I'm already doing. And that way I will trust the output more. Could you talk to me a little bit about how this is different from segment anything, for example? Because this is kind of like, give it an image and it segments everything in the image. And people seem to love that. And it seems to work really, really well. And this reminds me of your original approach. Like, give me an image and I will vectorize the whole thing. Could you just explain to me and the listeners, please, why these two things are different and why, yeah, I think that would be really helpful.
Right. So segment anything is extremely powerful, but it's powerful in a few specific characteristics. The first one is that it's grounded in text descriptions of what you're segmenting. So if you take a very large satellite image, for example, I think the best use case for segment anything is really satellite and aerial. And you can textually describe the geometry that you are extracting. Then I think segment anything, and I believe segment anything geospatial, the package that actually implements it specifically for geospatial software, is probably the best thing that you have. And so if you load drone imagery that you just took and ask it to segment out the lake boundary, that's pretty much the best thing that you can get. I think where our AI autocomplete is preferable to segment anything is especially when you are digitizing geometries that you have a semantic understanding of, but are difficult to textually explain, or you are digitizing lines that are difficult to semantically extract from that map. And so, for example, we often see a lot of extremely low quality. Maybe there's a lot of JPEG artifacts on the map. Maybe the resolution is pretty low. It was originally rendered to be really low. Or even there's artifacts from the original scan. Those are kind of maps where segment anything struggles. It's much more difficult to get segment anything to extract a line of a pressure sewer such that the line is a dashed line that has PS intermittently interrupting the line style. Whereas on the other hand, our AI autocomplete, because it looks at basically the line that you have already started, it excels at just completing it.
Okay, the line that you have already started, in the same way autocomplete works. So if I'm using ChatGPT, for example, some people have described it as a fancy autocomplete, where it says, okay, your question was this, the next logical token is this. in the same way we see it autocomplete in Google Docs, for example. It looks like the next logical word is here. So when you say autocomplete, you mean I take my pen tool, I start tracing the line, and it jumps ahead of me and says, oh, it looks like you're going on this line here, and follows it along. Am I correct?
That's exactly right. So the way our AI autocomplete works is it's a drop-in replacement for the pen tool. And so if you activate our plugin in QGIS and begin digitizing some geometry, let's say for our example, it was a utility line on a raster map. Once you begin digitizing that line by drawing two segments, a small bit of that map will be sent to our inference server, and it will autocomplete 50 of the next vertices of that line. And these vertices are output by a neural network that we've specifically trained for this job. And so that neural network is literally looking at the pixels that you have already drawn so as to predict which of the map is actually semantically this same feature and which of those pixels it should choose as continuing vertices. And I've realized that this problem is actually much more complex than I originally imagined. When you and I are talking about digitizing maps, it's extremely broad and vague, and it can be difficult to imagine what those maps actually are. But the magic in AI autocomplete is not that it works on certain maps, it's that it works on your map. And so when someone uploads into QGIS a map that our AI has never seen, and yet is able to generalize based on the hundreds of maps that we've trained it on, that I think is the really impressive thing.
And so I think the example you have on your website is amazing, and one of the reasons why I think it's amazing is that you're tracing a dashed line. So just to describe this for the listeners, there's a video of a screen video, I guess, of you tracing or someone tracing a dashed line in QGIS, and which is incredible, and you can see the autocomplete working and being ahead of the pen. But I think the really incredible thing is that adjacent to that line, there is an identical line, and crossing over that line is another identical line. And yet the autocomplete knows that you want to follow this particular one of those identical lines. But to me, to the layperson, that seems like an incredibly hard problem to solve.
So I think early on, I underestimated that difficulty. And I'm actually very fortunate that my background kind of let me push through all of the complexities that came with solving this problem. And so I think if you kind of follow our journey on social media, it might seem as though we built this in a couple of weeks and all of a sudden there's AI in QGIS. But really, that's a total simplification of kind of this journey I've had in understanding what map digitization really meant, both at a semantic level for the people that do it professionally, but also at a technical level, and how you could teach a computer to truly learn the semantic features that these people are working with and can actually autocomplete ahead of them. And so to kind of dive into what is surprising about this, I feel like I actually have a lot of, as someone who's literally looked at probably 1,000 different maps over the course of building this AI autocomplete. And I've actually run nearly 2,000 machine learning experiments to get to this current AI autocomplete. And experiment one, I promise you, did not perform well at all. And if you are actually one of our users and you download QGIS, download our plugin, and try it out, you are actually running model 1854. And the 1853 models that came before that were bad in many ways, but the main important thing is that they weren't able to generalize into the map that you're looking at. I've realized that lines have so many semantic meaning that allows you to disambiguate between two lines, say when they intersect, and encoding that into the model has been pretty much the most important task that I've completed.
So hats off to you for continuing. I think if I got no, what do you say, 800 or 1,800 times, I would be tempted to give up, but you didn't.
Right.
And then finally you got a yes. But my guess is also that I guess you were, like during that process, you could see that you were getting better and better and better and further, closer and closer, I should say, to the goal. So my guess is you had encouragement along the way. It wasn't like hard no, hard no, hard no.
Right.
That many times and then a yes. So, but anyway, that's incredible. That's well done. Well done. Hats off to you. When I think about this, so digitizing lines is very impressive, but it's a step in the journey, right?
Right.
Georeferencing is another part of that. Great. So now I've got my lines, not to throw any cold water, not to rain on your parade or anything, but now I've got my lines. You've done a great job of that. I've got my lines. Now they need to land somewhere specific on the real world in order to be useful to me. And then I need to extract some metadata about those as well. Is there any part of this, the model that you've built today, the experience that you've had, the learnings along the way, that overlap with maybe the next step of georeferencing?
That's a great question. So I've been working simultaneously on both of these models. So the AI autocomplete for vectorization is something that has kind of crested this threshold of usefulness. For most of its time, it was not useful at all. And I also have a machine learning model on my computer that can georeference maps, as-built documents from architecture and construction firms, you name it, automatically. But it hasn't yet crested this threshold where it can actually save someone time. And it's interesting because these two problems, while they're both grounded in maps, they're actually totally different. Because the AI autocomplete is really about understanding the semantic nature of maps and the features that are depicted on them. Whereas georeferencing is actually a search problem. When you're presented with a map that you don't know where it came from, especially this is extremely common for consultants. If you are basically asked to georeference this map to a sub-meter accuracy, you often don't know actually where it is at all. And so you embark on this interesting search, whether you're using Google Maps, you're using aerial and satellite imagery, maybe OpenStreetMap, and all of these other kind of data sources that can help you locate where a particular map is. And the possibilities for that are like astronomical. We're talking a chess game, number of possible game positions. That's comparable to the number of possible ways a map could be georeferenced to sub-meter accuracy in the world, right? So it's actually extremely difficult, especially when the map only has a little bit of information. So if the map is just a picture of a building and 2 cross streets, I can guarantee you there are 1,000 roads in the United States with those street names. And so what people actually do is they go through and page through all of these possible permutations of where this map could be, and then they line up exactly where this building is. And so if you imagine an AI model for georeferencing, it has to do all of that plus more. And so you're synthesizing all of these different data sets as to all of the roads in the world, not just the US, obviously, all of the satellite imagery, or even high quality, high resolution aerial imagery that you can use to georeference an exact building outline, or maybe even the curb on a road. These are challenges that I've had while hand georeferencing maps, and building an AI model to do that same thing is surprisingly difficult. But I think it's something that we'll be able to do in hopefully 3 months.
It's interesting to hear you say surprisingly difficult, because no, it doesn't surprise me at all that is difficult, especially after what you just said, which makes a lot of sense.
Right.
But the good news is we have a bunch of filters normally on a map. You have a name, you might have street names, you might have metadata, you might have some coordinates in there. You might have something like this, and we can filter it down to, oh, okay, I know I'm looking in this particular town or around this address, just as an example. And I guess too, not all other data sets are great, base maps for digitizing against. So if you've got a PDF as built of some building, looking at really grainy satellite data is not going to be super helpful. It's not going to get you where you want to go. Maybe OpenStreetMap would be better, or another building layer would be better, where we're talking about discrete objects as opposed to pixels. So we can do things to filter that down. At least that's my sort of experience. Is that also your experience, or can you put some other words around that?
As someone who's tried to make this model and is also continuously improving it, there's even more complexity than you could imagine. We've done a few projects on like bulk georeferencing maps. And one of the really interesting parts of this challenge is things change over time.
Yeah.
And so we've gotten basically the equivalent of a truckload of PDF maps, and I've been asked to georeference these. And the complexity of that is like highway names change over time, right? Road names change over time. Buildings disappear and appear. And so when you're being at rivers like change direction as they flow. And so when you're being asked to locate a map, the map is actually a description of how it was at a certain place in time. And so that's another complexity that you're also dealing with.
Wow, yeah, it's a really good point. I hadn't thought about that.
Trust me, I hadn't thought about it either.
But you also said that you're hoping to have something working in 3 months' time, which just seems insane. What are your expectations to have working in 3 months' time? What do you think it is that will be working, and how will it work?
I think it's really about this threshold of human usability. For an AI autocomplete, we realized that the bar was that the autocompleted vertices are easy to delete in case they're wrong, but easy to continue from in case that they're right. So we find that a lot of our users are actually okay with mistakes because they can instantly repair them. Designing that into our QGIS plugin has actually been a great boon for its usability. And we're kind of looking for the same thing with this georeferencing model. It's actually of no cost to you to try and georeference something, acknowledge, even if you get an error message, or acknowledge that the georeferencing is not as accurate as you wanted it, and then go in there and georeference it yourself. And so you can imagine a georeferencing button in your desktop GIS software where you load a raster, and perhaps it doesn't have a CRS, perhaps the ground control points are wrong, and it automatically locates its location in the real world and aligns, like rotates that image, aligns it, and gives you ground control points to ground it in, in its actual location. And that experience is what we're essentially trying to emulate with an AI georeferencer.
Wow, so you would, that's a really interesting insight that already doing that, which sounds incredible, already doing that would save a ton of time for people and be a massive value add for them.
Right. And because they come into this task with the expected cost of georeferencing, because georeferencing something accurately can take upwards of 20 minutes. If I've had maps that go longer, but let's say 20 minutes as a good number. Because you know that it can take that long, the cost of actually waiting 10 seconds to have an AI model try it first, that's actually pretty good. And so that's kind of what I have in mind as I go about building this model.
Now, if we jump back to your autocomplete for vectorization, now that it's working, you've crossed that threshold of usability that you keep talking about. Does that mean that as the person's using it and creating these results, are they in a way creating labels and adding to the model as they do it? Yes, this vertex here is right. Yes, this vertex here is, no, that's wrong over here. Are they improving the model over time?
So not by default. So our plugin doesn't collect any unnecessary telemetry. So we obviously know when you've requested an autocomplete, but we don't track whether or not you keep that result. We don't track whether or not you delete the resulting completion, and we don't track whether or not you cut that completion at a particular point. All of these are kind of potential outcomes that could happen in the plugin. And so we don't track any telemetry as to those outcomes, and so we don't automatically add any maps to our training dataset. We do occasionally have conversations with our users where they request that we add their maps to our training dataset, and on occasion we will go and have them hand digitized. We have a GIS staff that helps us with that, but by default that's not happening.
Is that in the interests of privacy, or is it because that data would not add any particular value to the autocomplete model in the background?
It is definitely in the interest of privacy. Yeah.
Let's say so what you're saying here is that it would be better for the model. We could make a better model if we collected that data, but in the interest of privacy or not. I realize earlier on you said that these are two different problems to solve. The autocomplete is a semantic problem, and the georeferencing is a search problem. Assuming that we didn't have to think about privacy issues here, if you also collected data for the georeferencing that people were doing, could you also improve that over time?
I think you could. I think, as with most ML models that are kind of deployed on the internet, seeing how it's actually being used in the real world is valuable information. But at least for us, we found that we can collect really high quality data without having to go into our users' data. And I think that's a great trait that we've kind of found ourselves in and a great position to be in.
Yeah, absolutely. So you sound incredibly talented, and I'm an optimist. So let's say in the next few hours, when you've solved both these problems perfectly, and you're ready to move on to one of the next steps in the process, which is adding metadata. Now that you've solved the autocomplete problem, you've got a model that works 100% of the time, you've got a georeferencing model that works 100% of the time. How will you start work on collecting metadata? What will that look like? What will be the steps involved and the potential output?
The metadata is really interesting because I think it brings the semantic understanding of the map that someone is digitizing to a totally new level. Because when you see people extracting all of the relevant metadata for a particular project, really, it's not at the point where you're ingesting metadata, it's not about a particular map. It's how the map fits into your overall project and the goal that you're trying to accomplish. And so if you are doing construction in an area and you want to have a complete understanding of all of the buried utility lines, such that in the case that you need to actually dig around these and what's called daylight them, which is when you dig exactly around them such that you can see them with your own eyes, all of that metadata that would help you accomplish that daylighting process is actually your goal. And then the metadata extraction is just how you get there. And so I think this is really where the application of multimodal models can really accelerate this process. It's because when we combine the intelligence that we can generate about a map, along with the visual and textual data understanding that an LLM can provide, it's only with that larger context that metadata extraction begins to make sense. And so if you go into GPT-4 with vision or some of the other multimodal models that are available right now and ask it to describe a particular feature in the image, it is totally incapable of doing that. And that's really not surprising. This data is not in these models' training data sets. And so it's not surprising that by default, you can't get this kind of behavior from these models. That being said, it's something that I know is possible. And so I'm really excited to be a part of that future of making it.
Yeah, I guess what I'm trying to understand is like what kinds of attributes would you be able to collect? What kinds of metadata? Because for me, it would make sense that maybe you could calculate the distance of that line, just as an example. Maybe you could look at the color of the line that you have just auto-completed and say, well, I know that matches to this thing over here in the legend of my map, if that's things. And then there might be some data associated with that. It might say water pipe, sewage pipe, I don't know, gas pipe, that kind of thing. That would be valuable data to have in there. Maybe I've digitized other lines. Maybe it could say, well, this pipe is, so close to the other pipe. Maybe you could start building up this like database based on the metadata that you're collecting about each object, based on its physical characteristics, based on whatever else is in the map. That's the way I would think of it, but I'm sure you have other ideas.
So in terms of metadata that a user could probably extract from these maps automatically, a really simple example is data on a legend, but that's not really the exciting applications. Data on a legend is like pretty easy to extract. And so it's not really the level where you're saving a GIS analyst or a GIS technician a lot of time. It's really about metadata that's hidden in these maps. And so I'm going to continue with this subsurface utility example, even though it's kind of misleading. If you were to daylight buried utility lines, you would do it would be a more complicated process to actually do that. And you wouldn't do that with just QLD raster images, raster maps. But hypothetically, really important metadata to know if you were daylighting a particular buried utility line is actually the depth of that line. And also the trait of the soil that it's buried in. These are kind of important things for the construction crews to know if they were to be delicately digging around a gas line such that it wouldn't have a dangerous utility strike. And so that's kind of a good example in the utility space. We also have kind of our users outside of architecture, engineering, construction. Another good example is actually mining and geology. And so if you are a geologist and you are dealing with kind of a older geologic map that describes the deposits in an area, the metadata associated with those deposits can be pretty complex, especially when the legend associated with that, it's not even about describing a solid color region of that map, but rather the matching the exact stylistic look of that polygon to a tiny little bit in the region that kind of says this is a sediment deposit of some type. And so it's metadata like that that we would want to extract automatically and actually embed into shapefiles or geo packages such that these projects can be accomplished more quickly.
Well, it looks like you have got your hands full for the next little while. More generally, are you surprised at the lack of AI being used in QGIS, for example, or GIS tools? And especially when we think of desktop tools? For me, like this is one of the few examples that I've seen out there in the world where it's being embedded into the actual tool itself, into the GIS tool itself. But maybe you've seen more, maybe you've seen less. I don't know, but I'd really like to hear your thoughts about that.
As an ML oriented person, I think there's a big gap between what is possible in desktop GIS software and what is already happening. So when people see large language models like ChatGPT, GPT-4, a lot of the other major developments that have been happening, especially in terms of video generation, audio processing, it's clear that pretty much all complex problems will eventually be solved by artificial intelligence until it relates to scarcity. I think unless you're talking about material scarcity, that is like literally the amount of food that's available on Earth, a lot of these problems can and will be solved by AI and ML. And I think it's only because we're at the beginning of this renaissance in machine learning that we see attention to it, but everyone's talking about it and nobody is implementing it. I think that's the best way to kind of imagine how this renaissance is happening right now. Obviously, OpenAI and these larger AI research companies are driving most of the innovation in terms of where AI is going. Meta being actually an extremely great example, who created Segment Anything and is releasing a lot of this groundbreaking research publicly. But I think most of the opportunity that exists in machine learning today is actually in building domain-specific models and embedding them into professionals' workflows. So I think GIS is a really great example of this. You can't take an LLM, even if it's memorized the entirety of the QGIS documentation, plus all mentions of GIS online ever. That LLM will often not immediately accelerate a professional's workflow. But once you understand that these large models are doing much more than generate text, they're actually generating semantic understanding of what you are asking it to do, and then completing that task as a result. Once you see that semantic understanding is actually what's being accomplished here, you can embed semantic understanding into all programs. And that program can understand your overall task just as much as you do. And I think we will see that trend more generally within GIS, within CAD, within all of these kind of desktop softwares. And it's not just about text autocomplete. It's really about augmentation.
If you weren't working on this problem of autocomplete with digitization of georeferencing, automatic extraction of metadata, and thinking again about working within and on top of the QGIS platform and solving problems for geospatial professionals that were using this as their main tool, what problem would you work on?
That's a great question. So pretty much all of my work so far has been around mapping the built world, or even the natural world. But an interesting opportunity for the geospatial world to move towards is less about mapping its current state, but more about imagining what's possible. And there's a couple of examples of startups actually doing this, where you take your conception of how the world is now and pretty much synthesize a way that the world could look in the future and evaluate whether or not that version is better. There's some really great advancements in how people are doing this to, for example, make the world a greener place, because geospatial software can literally find the optimal place to put a wind farm or a solar farm once you consider all of the complexity that's associated with that. But I think it goes much deeper than just real estate development. It's actually about evaluating ways on a map that the world is a bad place and changing that in the future. And that's really magical. A fun example of that is actually when you map out the street trees in a neighborhood. This is especially true in the United States, where you have kind of large roads and not much shade. They don't really encourage pedestrian friendly neighborhoods. But you can actually use machine learning and statistics on geospatial data to find the best spot to plant large trees and create more shade, create a better spot to walk around, and basically improve the nearby residents' lives. So I think if I wasn't building AI autocomplete for this georeferencing, vectorizing, and metadata extraction workflow, I would be working on changing what's actually in the map.
That was a great answer. I think I'm going to need a few minutes to walk around the house after this interview and think about that. So I appreciate it. You've really given me food for thought. It's also probably a great time to wrap up the conversation. Thank you very much for your time. It's much appreciated. And thank you very much for your work. I think it's fascinating. I think it's really interesting. And above all, I think it's going to be incredibly helpful to a lot of people. So if people want to check out what you're doing, where's the best place they can go? Can they reach out to you? Is there a website? Where can we send them?
Yeah, thank you, Daniel. If you're interested in seeing what we're up to, you can go to our website, which is Bunting Labs, BUNTING, labs.com. And you can also follow us on Twitter at the same handle. Yeah, thank you so much for the opportunity to share what we're up to.
Not a problem. Anytime. I appreciate your work and I wish you all the best in the future. Cheers.
Thanks.
So I really hope you enjoyed that episode with Brendan Ashworth, CTO and co-founder of Bunting Labs. And I hope that you take the time to check out their AI Autocomplete for QGIS tool. There'll be links to all these things in the show notes today. Or you can just Google Bunting Labs, BUNTING Labs. And thanks once again to our sponsor, Scribble Maps. As I mentioned in the introduction, Jonathan's been on the podcast before. He's the CEO of Scribble Maps. The title of that episode was The Business of Web Mapping, or The Business of Web Maps, sorry. It's well worth checking out. If you want to augment your current GIS workflows, check out Scribble Maps. Or if you want to bring GIS to all levels of your organization, Scribble Maps offers that sort of right balance of ease of use and functionality that you might be looking for. Book a one-to-one demo with Scribble Maps today and mention Mapscaping for a discount. Thanks, Scribble Maps. I really appreciate your support. So that's it for this episode. Thank you very much for tuning in all the way to the end. It's much appreciated. I'll be back again soon. I hope that you'll take the time to join me then.